Okay, folks, I wanted to throw in a quick video involving stretching or compressing of functions rather than general relations. So I'm going to take the following example. Suppose y equals f of x, okay? I could actually rewrite that as negative f of x plus y is equal to 0, and then consider the left-hand side of this equation to be a function of both x and y. In this case, I called it g of x and y, and that would be set to 0. So that would look like the situation that we've been dealing with previously. Now, suppose that a and b are positive constants here again, okay? And I've got something like this. Y equals b times f of a of x. This would be equivalent to what? If I divide on both sides by the constant b, I would have y over b equals f of a of x, okay? And then moving the f on the other side, I would have minus f of a of x plus y over b equals 0. And so I'm making it look like what I did up here. And you guys can actually see, if I'm still calling this g of x and y, that this is actually what? G of ax, because I've replaced x by ax, and then y has been replaced by y over b, so I get g of ax comma y over b equals 0. Okay, now let's compare these two then. This would say what? I'm multiplying by a on x, and then but I'm really doing what? Dividing by b on y. So let's take a particular example here. The graph of y equals 3 times f of 2x is the graph of what? Y equals f of x. Now look what we're doing with the x first here. We're multiplying it by 2, so that means you want to take its reciprocal, compressed by a factor of a half. Remember, it's a compression because that factor is less than 1. Compressed by a factor of a half in the x direction. Okay? Now, if I was to write this with the 3 on the y, it would be y over 3. So my b is acting like a third, right? When I take its reciprocal, I get 3 again. Okay? So if you guys see here, and then that means a stretch by a factor of 3 in the y direction. Oops. Now in the case of functions, this second part is probably really easy to see, right? That this is being multiplied by 3 here. So this is being stretched by a factor of 3 in the y direction. But here I'm showing you when we write it this way, this is completely consistent with everything we've done so far involving stretching or compressing relations. Okay? It's a little easier, though, in the case that we're dealing with y as a function of x, I think. Okay, so I just wanted to throw that in for the sake of completeness. Okay.